Hello and thank you for joining us for Dassault CATIA's latest webinar with Car Design News. My name is Owen Reedy and I'm the editor of CDN. As you know, this webinar will focus on interior cabin design and CATIA Creative. Over the next half an hour or so, we'll be joined by a team of experts from Dassault, Xavier Malconian, Fabio Bellari and Pierre Maillot, as they demonstrate how they broke the frontiers between automotive and aerospace and present their innovative process development of an aircraft interior design. Between them, Xavier, Fabio and Pierre bring a wealth of experience and expertise in industrial and product design, as well as collective years of skill and knowledge in CATIA design. As you follow their Loft-Jet cabin design from the very first sketch to high-end renderings, please submit questions for them to answer after the presentation. You can ask these questions by typing them into the bottom right-hand side of your screen. And if you happen to experience any technical issues during the session, please message into the same box. I'm sure that this is going to be a very interesting and fascinating webinar. So it's now just time for me to hand over to Xavier so they can begin their presentation. Over to you. Thanks.
Thank you, Owen. So hello everyone. Thank you for joining this webinar with Car Design News about how to use the CATIA design solutions for interior cabin design, from creative design to advanced surfacing with CATIA Icem. So as you know, CATIA is widely used in the Aero industry already, mainly in the mechanical surface or technical surface, but also in the surface refinement area with lofting design. Today we are intending to present you a new aspect of CATIA design solution in the industrial design field, mainly into the interior cabin design. The goal of addressing also this new market with CATIA is to offer to our customers and market a complete solution, allowing Aero companies to go from industrial design to lofting design surfaces to mechanical surfaces, to improve the collaboration between all the organization through all the creative process, from the early styling ideas to technical surfaces and Aero surfaces. So the topic of today is really to focus on creative design, especially interior cabin design. And with our solution, we want to address let's say, the four key challenges of Creative Studio. First of all, to help creative designers to develop creativity with innovative 3D sketching and concept modeling solutions, but also at any time to be able to take accurate strategic design decision with physical prototype, but also with very advanced high-end visualization tools. The third point is also very important, to help the design studio to collaborate with the rest of the organization, from engineering to manufacturing, and then also to improve the perceived quality of the product design. So for that, we have introduced since 4 years now a new solution called CATIA Creative Design to really cover the complete creative workflow with a unified industrial design workflow solution that you will discover during this presentation with Pierre Maillot and Fabio Bellari. The second aspect of our strategy is really to bring 3D accessible for the creative people, to make it simple, and that's why we have introduced some innovative technology like 3D sketching or virtual clay modeling, to really bring back 3D easy to use and accessible by creative people. The third point, which was very important for us, was also to help to streamline the design engineering collaboration. That's why it was very important for us to address also the creative people with a dedicated solution on the same platform, which is CATIA. And then with the 3D Experience platform, the V6 architecture, we also help the creative designers to be connected to their global network of designers and engineers. Having said that, as an introduction, I will now give the end to Pierre Maillot and Fabio Bellari to illustrate the aircraft cabin design with CATIA Creative Design and CATIA Icem. Yeah.
Thank you, Xavier. Welcome, everyone. Here we go for the aircraft cabin design process. So let's start with what we have introduced with our new solution, having a new way of designing interior and cabin in aircraft industry by always starting with sketches, with 2D sketches. It could be digital or handmade. And that's something that we really want to keep as input for the creative work, is keeping the digital sketch and hand sketches being the starting point of the story. Afterwards, we will go through 3D sketches, and that's really something that helps us out to make this transition between the 2D and the 3D by keeping sketching and being able to do it in 3D. So that will be CATIA Natural Sketch. Afterwards, to give surfaces and give a proportion of your final object, we will go through a 3D design exploration with subdivision surfaces of CATIA Imagine Shape in order to quickly iterate in 3D and explore some of the proportion and size of our final object. Afterward, we will see with Fabio the 3D detail design with CATIA Icem and generative shape design, especially focusing on surface quality, but also adding details such as gaps and seams on the seats. All along the process, you will also see that we are delivering a high level of visualization all along, and we also have access at any time to interactive ray-tracing. This interactive ray-tracing allows us to do color and trim reviews on both the seat itself in order to validate the materials and also to iterate on the color and trim, but also having in-context visualization of our object, because here what we do is to design this seat in order to put it back into a full cabin design. And that's what we will see afterwards still with CATIA Live Rendering. Also being able to produce high level of renderings in order to do marketing. And afterwards we will connect to the real world back with some prototype. It's something that we won't be illustrating because CATIA is already pretty famous for that. So machine programming and C machining is something that is completely embedded inside CATIA. And we will illustrate 3D printing with showcasing some of the 3D prints, scale 3D prints of the seat that has been directly produced out of CATIA using our 3D printer partner Stratasys. So let's start now from the very beginning with 2D and 3D sketch. So in a short demonstration, I will show you how you can start, for instance, from a 3D context. Here it's the foot of the seat. You can quickly, by drag and dropping, import your sketches, so front views, side views, and use it as a reference to start your 3D sketch. Here, by combining several curves and keep on sketching, what I'm able to do is to create a full 3D curve, and then navigating into this 3D space, I am able to describe several other curves in order to give more inputs and describing completely my object in 3D. Again, at any time I can switch to perspective view, and that's the kind of results you can have after several seconds using CATIA Natural Sketch. As you can see, the interface is very simple, and we wanted to make it this way. Now, what the key value is being completely integrated inside a modeling software, so we are at any time able to generate a surface based on source curves. If we move the curves, then the surface will be changed depending on this variation. We can, of course, change the color of our brushes and adding some detail. And here, the interesting point is we're able to draw directly on the surface we just have created. So you can use any kind of support. It could be a 3D surface, but also a scan, a cloud of points, could be a support to be able to sketch on top of it. So here, for instance, and it's part of the process, is describing where we want to put the seam, and it's really giving the character to the final seat, and that's how you're able to do it with CATIA Natural Sketch. So very quickly, being able to switch and to transform 2D sketches into a 3D reality with a 3D sketch. Second point will be about the concept design itself. And for that, we will use subdivision surfaces, especially for this kind of design when you have very kind of organic shape. Subdivision surfaces are very flexible to be used in order to generate those shapes. So you can see that we start from a first surface that is already connected and start to deform it by pushing and pulling the mesh in order to generate the surface. So we are adapting it to the context of the foot of the seat. Again, we are fully integrated inside the rest of CATIA, so it could be coming from engineering, it could be carryover from the former seat, and natively you access to source data. And now using the interaction with the subdivision surfaces, we're able to add more details in order to do the armrest, for instance. And what is really nice with this kind of technology coming from movie industry at the very beginning is that you can freely add more subdivision and transform it in order to generate the final shape. Also giving more smooth or hard edge in order to generate the shape that you really want to generate at the end. So here, going a little bit further, again, all you can see here is like real-time demonstration. So you can see that in really few seconds you are able to generate consistent shape, and you keep on adding some details by translating the points and generating the geometry. So we will now focus more on the back of the seat, changing the size of it. We did not show it here, but because it's inside CATIA, you can also add, for instance, a human as a reference, so you are able to design around the human. You are also able to have as an input the 3D sketch I just made before, so it could be a 3D reference, a 3D canvas for the rest of the modeling, or you can do like what we did here, just having a free form exploration directly on the surfaces. We are also able, as you have seen, to manage the real-time symmetry. And it's also something you may have noticed is at any time we are generating the shadow between the objects in order to have a better idea of the final object. Here, it's a little bit further in the process. What we want to do is to generate a gap between two parts. We just are creating a new surface and then use it as an input to generate this gap. By also generating this cut, we also are generating the fillet in the same time, and it's all associative. So if you are modifying the cutting surface, here for instance, you will see that this gap line will be changed directly. It could be the same way by using a line that you have generated with a 3D sketching tool. Here is another modification, just to really meet the seat, the main cushion. Again, generating the fillet. Here, for instance, we are not satisfied with the fillet. At any time, we can change the size of it. What we wanted is, again, to do it very quick, and in a few minutes being able to generate your ideas in 3D and keep on iterating. If you want to change the size of it, change the armrest, change any part of it, it's very flexible to be changed. So now I will give the end to Fabio to go further in the process into detailed design.
Thank you, Pierre. So let's now have a look more about 3D detailed design. And for this, we will use a CATIA Icem solution and classical Bezier nerves modeling. Here is an example coming from the industry as a general seat. And the first thing we can notice that this seat, in the shape of this seat, is really high segmented. And in general, this means really bad quality of surface. So if we get closer and zoom in, we can notice that there are also some area where filleting is missing. And as well, we can notice some clashes that are visible, and some area that the connection and hole are present, and this really underlines the bad quality of this model. So what we made, we have made the exercise to remodel it back, and for this we have used CATIA Icem technologies, and if we are getting closer, we can see the kind of result we can reach with this kind of geometry and technologies. If we compare the previous model and the new one, you can appreciate the difference in between this kind of data. So the missing fillet are now there, clashing are no more available, and the general quality of the model, if you are looking at the gaps, is quite better. So how we can start with this kind of modelization. The first thing we had a look to the model. We can identify 3 different kind of area. The first one is an area which I call soft bump area, and this is because we really have the impression of this kind of bump, and it's covered by leather. The second area is what we call semi-soft area. It's still covered by leather, but is on top of rigid geometry. And the third area is what we call rigid glossy area. And here you see how we can differentiate this kind of area. For the first one, we have used some function like the accelerated surface of CATIA Icem and Imagine Shape. This really to give the impression of softness of this surface. We really wanted to avoid mechanical surface effect on top of this area. The second area is we have used some CATIA Icem parametric G2 modeling, and for the third one, as it is glossing and reflecting highlight, we really get closer to the smoothed explicit Bezier approach, like for instance we in Class A for exterior automotive. And thanks to CATIA Icem, we can reach really high and quality of connection up to G2 and G3, and we can really control the effect of this highlight on top of the surface. This really gives at the end an impression to have a luxury product. So let's now get in and dive into an example. This is really easy and basic example. We start from a subdivision surface, and then we move to surface conversion, and on top of it we had some accelerated surfaces. We close the corner with a patch from curves, as well connected up to G2 and G3, and then we close all the volume with the filleting. And this provides this kind of result. Another interesting capability, we have used some advanced CATIA Icem modeling capability to project and reuse standard component from the library. So in this case, this belt has been projected on top of the shape, and we are able to move this geometry, and everything will be adapted as it is associated. Another interesting part of the detail design is the automatic generation of the seams. So in this case, we are using standard CATIA capability like the knowledgeware in order to generate automatically this kind of geometry. So we just select some input like the surface and the curve, and choosing some parameters like the step, and here we are able to generate and iterate on top of this kind of geometry, really in an automatic way. And to conclude, as we cover the entire process, we are also able to generate the unfold surfaces, and this will provide us the area of the leather we have to cut, and as well the cutting boundaries of this leather. this is it for the detailed design. I give the end back to Pierre for the color and trim and the in-context validation.
Thank you, Fabio. So as you have seen, now we have a high level of surfacing on the product, and we're able to access to high-end visualization based on this geometry. So what is interesting here is that we directly are working on the native data, so there is no data conversion. So that's kind of a cloud color version of the model. We will just switch to the real-time visualization, and we use CATIA Live Rendering that is embedding interactive raytracing engine that is called Aero, coming from NVIDIA, in order to generate this kind of interactive visualization with reflections and global illumination for the whole cabin. Usually this kind of situation is very difficult to do because there is a lot of smooth shadow and indirect lighting, and so it's a really great challenge to be able to do it, and even to do it with interactive visualization. So in this example, we are able to change the exposure a little bit in order to generate exactly the visualization we want to have. What we did is also having something very close to the photographic experience in order to have a very simple way to generate image and to address to people that are photographers as a background. Now we're using what we call the background rendering in order to be able in parallel to generate very high-end renderings in parallel of your keep-on modification or modeling. Because here again, also surfaces, you can keep on changing them and just push a button and see the results with ray tracing, global illumination, and smooth shadow. So here are some of the results of the color and trim variation we made. So as you have noticed, we were able to generate the seams, and we can use it for the input of the color and trim variation. And we can both iterate on the color of the seam, the material of the seam, but also the size and the space between each of them. Now let's focus on variation about the material precisely. So here, for instance, on the armrest, as Fabio did generate by map a 3D model on the armrest, we're able to do variation between several materials, changing the color, of course, but also the finishing, if it's glossy, if it's brushed, if it's satinated. You are able to generate also the materials, and you can check the interaction here, for instance, with the reflection of the seam on the model. Other example is about leather. We did generate advanced material with very high level of realism, combining technologies such as bump maps and advanced shaders. And so we are able to switch between several iterations in order to take at the end the final decision about the material and the color. Let's go a little bit further about the lighting itself, because as you are inside the cabin, you have the outside light, but you also have additional lights. And you want to be able to see what is the variation between those two configurations with the light on and off, and that's the kind of thing that you are able to generate. Another strong point is about the global harmony and atmosphere inside the cabin itself. So here, for instance, we're able to do some variation on the roughness on the side panel, the plastic side panel of the whole cabin, and see the impact on the global lighting of the cabin. So here again, it's on the native data directly. You are able to do those variations, again, to be able to take the right decision and to find the right choice for your final customer. About material variation, you have seen it on the seat itself, but you can, of course, do it for the whole cabin, changing the finishing from glossy to reflective, and see the impact on the final cabin design. And here again, no data preparation. You can directly on the model, even if it's not finished, do those kind of rendering in order to take the right decision in parallel of the modeling. Now you can imagine that you freeze the design and you want to do some communication about your model. You are able to generate those kind of high-end rendering, combining two renderings from the interior and exterior, and also do some very high resolution images, for instance, of the whole cabin, as you can see here, with all the details and also some indirect lighting and also additional lighting combined. But now let's have a look about how we did those kind of renderings, especially those marketing renderings. First of all, just you to understand here, what you have seen is a full definition of the plan, including all the detail and even the engineering itself. Again, what you have to have in mind is, because we are inside CATIA, we are fully integrated inside the modeling environment, and all the geometry we are retrieving will be the geometry that will be produced in the end. So you can see here the engine with a full detail engine generated by the engineering department. You can see the additional value of the ray tracing by having the reflection between the objects. And here, just as a quick example of what I was saying about being able to change at any time the modeling, here we will just change the number of blades of the engine and being able just pushing back the button to access to the ray traced full high-end rendering of the object. So you've seen it here for the engine. You can imagine the same way for the seam on the seat, even the table in the cabin, or the cushion and the seat geometry itself could be changed, could be modified, and you can check in the whole context of the whole airplane, including interior and exterior, the impact of those modeling changes. So now we did illustrate this integration of the rendering engine inside the modeling environment. What we will be able to do is to switch back to the interior. So because we have the full airplane, both interior and exterior, we will just go through the wall of the cabin and enter inside the cabin itself. So you can recognize the model that Fabio was presenting, and we will retrieve a camera with the view angle to be able to see the whole cabin. So it's a very wide view angle. What we did introduce also in our latest version of CATIA is having those kind of post-effect visualization. So you can have a hand sketch kind of visualization, ball pen or graphite pen. You can have some watercolor, and all those are real-time visualization, so you can still navigate inside your model. Here it's something close to the cell shading you can find in some video games. A more sketchy kind of vectorial way to sketch, and some engraving old school version. So again, all those are complementary to the ray tracing. You are able to have real-time visualization in the same time having at any time ray tracing to have reflections and smooth shadows between the objects. So we will go back to a more photographic production. So we are deciding of an environment, here a sky with hard sun. You can see that we already see the reflection of the window in the table, a glossy table. We are changing the exposure, and here interactively we can see the impact of changing the exposure in order to see the global feeling of the cabin with whole indirect lighting. So all the light is coming out of the window and the environment. Afterwards, we will be able to show how you can light up and combine the two, exterior and interior lighting. So what we will be able to do is to say that at any time there is material that does emit light. All the thing you see is again interactive, so the computation is done in parallel using both the processors and the graphic boards. So what we will do is to decide interactively about the point of view, about the geometry, about the materials, about the lighting, and when we are able to say that everything is correct, we're able to launch a complete high-resolution image in order to generate those marketing images. So we will see the transition between a few seconds rendering and a couple of minutes. So you will see that we reach a very high level of quality. And now we will be focusing on another area when it does make a lot of sense to have both interior and exterior, because we will be able to see the winglet on the side of the main wings of the airplane directly out of the window. So we take this position, we are starting the rendering, and we can already see this winglet through the window. And what we want to do is to produce a high-end image as you have on the left of the screen. So at any time we are able to check the reflection between the object, but also to highlight through an emissive texture the tablet that you have on the table. So as an input we are giving an image, and it will generate both the image itself as a texture, but also an emitting light texture. So depending on the pixel of the image, you are generating a lighting that is coherent. Now we are satisfied with the setup, lighting, camera, materials, even the tablet itself. And so we are able to generate very high-end rendering from here. So we will start this rendering, and in the background, we can keep on working on this project. It will be computing a very high-end image. So you can see that we have a list of a couple of images that you can have sent, and it will start to compute using both processors but also graphic boards in order to take full power of your hardware. So here it's the very first iteration, but after a couple of minutes you can see those kind of results that we made and did present during this presentation. So again, having those kind of capabilities allowed you to take the right decision and about your materials, about your geometry, and about your lighting. At any time we are able to generate the several passes, so it could be about the specular, it could be about the reflective path, in order to do afterwards, if you need to, some compositing on any 2D compositing software. And while we were watching those images, the final image did compute, and we go through all those passes. So that was it about how to generate directly out of CATIA some very high-end renderings. Now we will go through the prototyping process using STL rapid prototyping and 3D printer. So how we do is starting from the final model we did inside CATIA. Still inside CATIA, we're able to generate the STL file that will be an input to the 3D printer. And using a 3D printer, we're able to generate in one shot the seat. Interesting point about this 3D printer is that it's able to generate in one print a several material output. So here you can see that the color of the plastic is different between the armrest and the rest of the seat, and also the mechanical properties, for instance being soft or being hard plastic, is generated in the same time. So here is a variation of a couple of seats we did generate directly out of the 3D printer in a couple of hours of 3D printing. And again, it's directly the data you have seen being designed by Fabio, the same data you've seen through the renderings, and the input you had from the very beginning with the 3D sketching and the subdivision concept design. Additional to that, complementary to the rapid prototyping, you also access to immersive room and scale 1 room. Here, for instance, it's a 5 meter by 2 meters screen with a very high resolution that is 4K in order to really deep dive inside your final model in order to take the final decision. It could be complementary to virtual prototype and real prototype, and you can even compare a virtual prototype with a physical prototype. Additional to that, we also are delivering immersive experiences that does access to stereoscopic glass and also head tracking in order to be completely immersive and being able to even move your body inside the final cabin. So just to wrap up, here are some of the answers to the cabin design challenges. First of all, about being able to develop the creativity and propose more and more design proposal. What you have seen with 3D sketching has been done with some designers that never used CATIA before. So without training, they are able to generate those kind of 3D sketches. Another point about being able to generate that is using this virtual clay. We are able to propose many designs. About convincing, you have seen that without any data preparation, we're able to propose and take decision at any time. So if you have your design manager just asking you where you are at, you don't need to prepare anything. You just push a button and can providing the right level of visualization to take decision. Same thing for your color and trim designer. At any time, you can generate some renderings and take decision according to the in-work surfaces. So your model can be still under progress, and you can already take some decision about color and trim. Because you know that the shape does influence the material, and the material also does influence the perception of the shape. About the collaboration, you have seen that we are fully integrated inside the software that is also used by the rest of the company. So without any data conversion, you're saving a lot of time that then can be used for your final goal, creativity and perceived quality. Also, by being integrated inside the same environment with the rest of your technical engineering department, you can exchange with them, especially on potential issues, and anticipate them in order to provide a better design by integrating earlier the technical constraints. Last point about the perceived quality, you've seen that we're able to generate very high level of surfacing, and we can reach a higher level of quality about the surface, and also use this surface quality to generate realistic renderings in order to take decision. For instance, on perceived quality, you can take decision about gaps, about the size of your seams, and things like that. Last point is, all you've seen are CATIA surfaces that are already usable for NC machining, 3D printing, you have seen it, and even manufacturing, because all the things that you have seen are 3D that will be used as an input for the manufacturing. So I think we did wrap up all the thing. If you want to connect, don't hesitate to connect to the CATIA Creative Design community in order to see what has been done by the community of designers using CATIA. And if you are interested and want to have more information, don't hesitate to contact our local contacts all around the world, America, Europe, and Asia. And I think we are all done, so I will give back the end to Xavier.
Thank you, Pierre. Thank you, Fabio. So thank you for your time, gentlemen. I think it's time for questions and answers as we have more time. So I'm checking if we have any question from the GoToWebinar panels. So if you have any question, you have a specific tab on the GoToWebinar panels to ask any question. Okay, I don't see much questions.
Hi everyone. As we mentioned at the start, if you have any questions for the panel, please do put them into the box on the bottom right-hand side of the screen. I know that earlier a few people may have been experiencing some audio problems, so apologies for that if that was the case. But the question and answer session is now open.
Okay, I don't see any other questions. Oh yes, there is one question. On which release the demonstrations has been performed? So in fact, it was on version 6, release 2014. And for live rendering, it was on release 2013X. Okay, gentlemen, so I don't see any other question. Oh yeah, there is one new. Is this CATIA V6 centric? I'm not sure to really understand the question, but yes, all the demonstration and presentation, in fact, it's based on a workshop that we did on that subject is based on version 6. But most of the tools that you did discover, like Imagine Shape for virtual clay modeling with subdivision surfaces, is also available in V5. CATIA Icem for advanced surface modeling is also available in V5. Developed shape technology to develop surfaces, to wrap and unwrap surfaces, is also available in V5 and V6. The only two exceptions, which are only available in V6, are Natural Sketch for 3D sketching and CATIA Live Rendering for interactive rendering and global illumination, including rapid prototyping, STL, is available on both V5 and V6. So there is a question about the stitching, the SU. You know, on the seat design, we did add with patterns and knowledgeware some automated stitching. So this is available in V5 and V6, and this pattern is available on the CATIA Creative Design community for free. So if you join the community, if you go to the 3ds.com website, you can join the community, and you will see there is a section dedicated to content, which includes some knowledgeware and patterns, but also some materials, environments for rendering, shaders libraries, environments, even 3D objects, which are really free for the members of the community. Okay, there is another question saying any direct 3D printing function in CATIA. I'm not quite sure to really understand the meaning of the question. So we can do 3D printing in CATIA, as you saw. Right now, it might require a little bit of work depending on your model and the quality of the model or what you're expecting to print. So there are multiple tools in CATIA to do a little bit of pre-work. Like for example, if you don't want to print objects which are not visible, there are some automated removal of hidden objects before 3D printing, or you can optimize the tessellation before 3D printing depending on the printer you have. Or if you have some advanced printer doing multi-materials or multicolor materials, you can also organize your model within CATIA with some different tools. So most of the time it's not just one push button to go to 3D print. Most of the time you need to prepare some pre-work to go to 3D printing. Or if it's a basic one, yes, you can just do an export STL and then send it to the 3D printer. I think we have a dedicated masterclass also on the community about 3D printing and all the tips and tricks in CATIA V5 and V6 to prepare data on the 3D printing. So again, if you go to the 3ds.com design community, you will be able to replay these masterclasses. Any 3D printer support like in Windows 8.1? So as of today, no, there is no direct support of a 3D printer directly from CATIA. Okay, I think it was the last question.
Okay, yeah, I think you're right. I think that's all the questions for this session. So thanks, guys. It was a really very interesting webinar. Especially interesting to see something slightly different on Car Design News with some aerospace content there. Thanks so much for joining us, everyone, today. Do remember that this webinar has been recorded and it's going to be uploaded onto Car Design News over the next couple of days. So if you'd like to watch again or share with your colleagues, then just look out for that on CDN. It's going to be under the Processes tab on the CDN homepage. Thanks again, everyone. Thanks to the team for the presentation. And please don't forget to join us again later in November for the next Car Design webinar. Thank you. Goodbye.